Hey everyone, it's Miss Hu, your physics teacher. In this video, we're going to go through the concept of power rating. Now, every time you buy an electrical appliance, you'll find that it comes with a whole bunch of numbers and you're like, oh my gosh, who knows how to read all these? Well, there's a couple of numbers that you should know, and they're really quite easy to understand. So let's look at an example over here. Say we have a light bulb that has been labeled 240 volts, 18 watts. It's quite self-explanatory, but I'll explain anyway. Now, the 200 volts here, the voltage over here, this is the voltage that you should connect this light bulb ideally to. You can try connecting it to other voltages, but there could be problems. So for example, if you connect the light bulb to a voltage that's much lower, like say for example this is 240 volts, but you go and connect it to 12 volts, the light bulb might not even light up at all. Or if you connect to a voltage that's too high, like let's say you try, okay, let's try 1,000 volts, the light might actually burst. So this is the ideal voltage that you should connect this light bulb to. Now when you connect the light bulb to 240 volts like this, for example, so say 240 volts power supply, you take this light bulb and connect it to 240 volts. This light bulb will use 18 watts of power, or can also be expressed as 18 joules of energy per second. So that's what power rating is. So power rating is actually a pair of numbers, not just one number. So a lot of people think, oh, 18 watts is the power rating. No, 18 watts is the power, 240 volts is of course a voltage. Together, this pair makes the power rating. Because if you connect this light bulb to different values of voltages, it would end up using different values of power. And no, the value is not directly proportional. So anyway, just focusing on these numbers. So when you have this kind of light bulb, you connect it to 240 volts. This light bulb will use 18 watts of power or 18 joules of energy per second. So I'm going to write that out to make this a little bit clearer to you. So when the light bulb is connected to 240 volts, say power supply, it uses 18 joules of energy per second. That's what it means. Now, another thing that you should also understand is this. This light bulb has been manufactured and designed to produce this 18 joules of energy per second, or 18 watts, when you connect it to 240 volts. So why this number specifically? Because this is the optimal brightness that the light bulb will work at. It doesn't mean that it's the highest brightness, or it's like the lowest brightness. Okay, that doesn't even make sense. It's not the highest brightness. It is more like this is the brightness that's just right, and it has been designed to work well for the use that you want it to. So you will come across this term normal brightness, right? And what this normal brightness means is that this particular lamp at 18 watts, that's that brightness at this point, that's the normal brightness for this particular lamp or light bulb. So I'll just add here, it shines with normal brightness. So in case you're wondering what's normal brightness, that's what it means. So normal brightness here refers to using this light bulb at the stipulated values that the manufacturers have already suggested. Here's another example. Now, for this particular light bulb, it's rated at 12 volts, 7 watts. That means for this particular light bulb, you need to connect it to 12 volts of voltage for it to be able to function at the correct rate, which has been stipulated by the manufacturer. So when you connect it to 12 volts of voltage, this lamp will use 7 watts of power or 7 joules of energy per second. At this point, this light bulb will light up with the normal brightness based on this power rating. So that's what this means. So when we say that we connect it to, this light bulb needs to receive 12 volts of voltage. So what if we connect this, for example, in series? So now let's say we take 3 identical light bulbs and connect them in series like this. So each light bulb is 12 volts, 7 watts. Now, connecting it to 12 volts of power supply is not going to enable these lamps to receive 12 volts. So they will not be lighting up with normal brightness. For each of these lamps to light with normal brightness, they each need to receive 12 volts. So this is not going to work. Therefore, you need to connect this to 36 volts. That way, 36 volts will be spread out here. This gets 12, this gets 12, this gets 12. Now, each of these lamps will be lighting up with normal brightness. Each of these lamps will be using 7 watts of power or 7 joules of energy per second. So you have to make sure that each bulb is actually receiving the voltage it's supposed to receive based on the power rating. So let's have a quick comparison between these two kinds of light bulbs. Now, on the left-hand side here, this is the kind of light bulbs that we tend to use nowadays. These are power-saving light bulbs. So they could be LED or they could be fluorescent light bulbs, depending on how they're manufactured. And this is the old style light bulbs, which are filament light bulbs. So nowadays, we don't like to use these kind of light bulbs. In fact, I think they have been banned in several countries. And the reason for this is because these kind of light bulbs are not very efficient. So looking at the numbers here, right? This light bulb, say for example, it's been rated 240 volts, 18 watts. That means that you connect this light bulb to 240 volts, power supplies. If it's receiving 240 volts of voltage, it will be using 18 joules of energy per second or 18 watts of power. This light bulb, however, connected to the same voltage is using a much higher value of power at 60 watts or 60 joules of energy per second. Now, typically, when we compare these light bulbs, we would compare two light bulbs that have the same kind of brightness. So, okay, you can argue that they're both normal brightness when they get the same voltage, but at the same time, when we look and we see, ooh, the brightness, and comparing the brightness of two different bulbs. Let's say, for example, these bulbs have the same level of brightness, but because this bulb has a much higher energy usage, that means this light bulb is actually using up much more energy compared to this bulb. So why we call this power saving or energy efficient bulbs is because to produce the same level of brightness, it requires much less electrical energy compared to this. And it comes down to how the energy is converted. This kind of light bulb converts electrical energy to heat and light, with the majority being heat energy and very little light. While this bulb can also produce heat, that means it also converts electrical to light and heat, the level of heat produced is much, much lower compared to this bulb. So just to help you visualize this, electrical energy is converted to light and heat for both. But this bulb tends to produce much higher values of heat. So for example, it could be producing maybe 10% light and 80, I can't even do my math, right? 90% heat. Whereas this bulb could be producing 90% light and only 10% heat. So therein lies the comparison over here. So that's why these two bulbs can produce the same level of brightness. It's because it depends on how much energy was converted to heat. So filament light bulbs work by heating up the filament. That means the current flows in, heats up the filament. The filament then, once it glows, it converts some of the heat to light. This bulb works differently depending on what kind of bulb it is, but generally it doesn't produce heat to produce light. So there's a method in here that's able to produce the light energy, and then some of it may be produced as heat because of the electrical current that's flowing through the circuit in general. So that's the comparison between different kinds of bulbs, and that's why nowadays we tend to use power saving bulbs because it uses much less energy, much more environmentally friendly as well. Now, power rating doesn't apply only for light bulbs. It can also apply to other electrical appliances. In fact, all electrical appliances have power ratings. So for example, if you have an iron that's rated at 240 volts, 1.1 kilowatts, what this means is that if you connect this iron to 240 volts power supply. That means it receives 240 volts of voltage. The iron uses 1.1 kilowatt of power, or you can say it as 1.1 kilojoules of energy per second. Now, the concept of normal brightness only applies to lamps. So you don't say, oh, normal heatness. That doesn't apply in this case. So you just, if you're asked to elaborate on a power rating for appliances that are not light bulbs, you can stop here. You just mention the numbers and that's good enough. So in real life, how do we also read the numbers? So for example, let's say you have a laptop. And if you look, oh, a whole bunch of numbers here, let's look at the numbers. So this laptop, if we flip to look at the adapter, for example, you see the adapter here is written 170 watts. And if you look at the input here, okay, say it's about 100 to 240 volts. So let's say 240 volts because say we connecting this to a Malaysian power supply, 240 volts. So when connected to 240 volts power supply, okay, the laptop uses 170 watts of power, or you can say 170 joules of energy per second. So this is how you can interpret the numbers that you see on your electrical appliances in real life. And that's it about power rating. So I hope you found this video educational and helpful. Don't forget to click like and subscribe for more lessons, solutions, and exam strategies by your physics teacher, Miss Ho. Happy studying!